Let us solve one more problem for from IIT-JAM 2023, and the question number 30 on section B, and this is basically from waves. In that question it is mentioned that you have a traveling wave along x direction, and y is the displacement of this wave and v is the velocity, and that wave can be described by which equation that you have to check, and this is basically MSQ question. Okay. Now these waves, when it is traveling along x direction, now see the interesting thing here, they didn't mention that wave is traveling along positive x direction or negative x direction. Okay, they didn't specify it. So for this wave, the displacement I can represent like some amplitude a times sine of kx minus omega. So since they didn't mention that it is traveling only along positive x direction or negative x direction, so I have to take both possibility. So this wave is representing that your wave is traveling along positive x direction. How that I'll explain. And I have to take that wave displacement as a into sine of kx plus omega t. Okay, and a is maximum displacement. This is representing wave is traveling along positive x direction. This is representing wave is traveling along negative x direction. Why I am taking? Because they didn't mention that wave is traveling in a specific, whether it is positive x direction or negative x direction. So that's why I have to take both possibilities. Now, how you'll understand this wave is traveling along x direction? Just you have to keep that phase factor kx minus omega t, that is equals to 0. So this is the way to understand that wave is traveling along positive or negative x direction. And this thing, that kx, this factor is representing the direction of propagation. If I am taking that k z here, then it means that wave is traveling along z direction. Okay, so if I am taking like kx plus y, it is the meaning of that your wave is traveling along both x and y direction. So this factor is representing the direction of propagation. But whether it is positive or negative, how will understand that? Just you have to keep that phase factor equals to 0. Now here you have to find that expression for x, that will be omega t by kx. Now I can see with progressive time there is an increment of x. जैसे जैसे टाइम बढ़ाते जाओगे x का वैल्यू बढ़ता जाएगा. इसका मतलब क्या हुआ? Your wave is traveling along positive x direction. Okay. Now, but same if you see here, if you keep kx plus omega t equals to 0. Now, if you find that expression for x, that will be minus omega t by k. Okay. Now, with increasing time, there is a decrement of x. What does it mean? That your wave is traveling along negative x direction. So I have taken both possibilities since they didn't mention. Okay. Now what I'll do, I'll differentiate this with respect to x. So dy by dx, that will provide a into k cosine of kx minus omega t. Okay. Here dy by dx, I'll get ak cosine of kx plus omega t. Okay. Now, if I differentiate this displacement with respect to time, so dy by dt, will be how much? So you have to differentiate with respect to time. That will provide you this this sign will convert it to cosine. If you differentiate this factor with respect to time, that will provide minus omega. So basically, you will have minus a omega, then cosine of kx minus omega t. Okay. And if you differentiate this with respect to time, what I'll get dy by dt, that will be a omega cosine of kx plus omega t. Okay. Now omega is how much? Omega is nothing but v into k. Omega is nothing but v into k. So that I can write in place of omega, I'll substitute v into k, where v is the velocity of your wave. So I can write like v into a into k cosine of kx minus omega t. Okay. Now I can see this factor. This is nothing but dy by dx. So it means minus v into dy by dx. So you have a dy by dt, that is nothing but minus v dv by dx. Now if you bring minus v this side, you will basically get dy by dx plus 1 by v dy by dt, that will be 0. So this wave I can describe like this when it is traveling along positive x direction. Same thing I'll do here also. So I can represent, again I'll substitute in place of omega, I'll substitute v into k, and I'll keep v as a first factor, then a into k into cosine of kx plus omega t. Okay, kx plus omega t. This thing again I can write like dy by dx. So it will be v into dy by dx. Okay, so this wave I can represent like dy by dx minus 1 by v dy by dt, that will be 0. So this wave equation I can describe like this also when it is traveling along negative x direction. Okay. Further, if you differentiate this with respect to time again, so that will become del square y by del t square. Del square y by del t square. If you differentiate, you'll basically get minus a omega square sine of kx minus omega t. Kx minus omega t. Okay. And if you differentiate this with respect to x, that will provide you del square y by del x square. And that will be how much? That will be minus a k square into sine of kx minus omega t. Kx minus of omega t. Okay. Okay. Now again I'll write omega equals to vk. So then we'll have, if you substitute in place of omega equals to vk, I'll basically get minus v square. Sorry, minus, not minus, it will be plus v square into del square y by del x square. Okay, del square y by del x square. So it means if I rearrange it, basically I'll get del square y by del x square equals to 1 by v square into del square y by del t square. Okay, and this same equation, the same equation you will get from here itself, here also. If you differentiate again with respect to time, del square y by del t square. Again, if you differentiate with respect to x, del square y by del x square. If you substitute it, you will get this equation only. So this will be the another representation of this wave. So I can represent like this when it is traveling along positive x direction, it will be along negative x direction, and this is the general equation of wave that we know. Okay, so these three way I can represent. Okay, thank you.